Hi everyone, it's Neil from Big Science. I have been asked to come along with the Christmas in Sundeland programme to do some science experiments for you today. Now usually when I do these videos I do them from my kitchen with some kitchen chemistry, but I thought as it's Christmas what better place to do these experiments than the North Pole. So I have come to the North Pole. I'm a little bit cold to do some little science experiments with you. Now I have asked Santa to help me, but I can't seem to find him. But I can imagine he will be a little bit busy at this time of year. But he might show his face a little bit later. Now what I thought I'll do, I'm going to do some science experiments with a Christmas twist. So here at the North Pole, I keep on finding these things all over the place. I cannot move for candy canes. So the first two experiments that we're going to do today both use candy canes. And then for the last experiment, what I thought I'd do is I thought I'll do one of my favourite big science experiments with a little bit of a Christmas twist. So there'll be 3 experiments that you can all do at home. You don't need to use any science equipment. It's all just things that you should have in your house around the Christmas time. Now I'm going to go through what equipment and kind of ingredients you'll need for our experiment. You might already know. However, I'm just going to go through them quickly just so you definitely know and you definitely have them at hand for us to all get cracking with our Christmas experiments. For the first 2 experiments using candy canes, the first thing you'll need obviously is candy canes, and you'll need about 5 or 6 of these. You'll also need a nice tray or a plate. I've got a nice Santa plate here. It doesn't have to be a Christmas plate, but I'm going to use one today. You'll also need some vinegar. And so this is distilled vinegar, it's white, it's clear vinegar, but malt vinegar will also work, but just this works better because you get to see a lot more. You'll also need some bicarbonate of soda or baking powder. You'll need some oil. Now I'm going to use baby oil again because it's nice and clear so you get to see a lot more. However, if you don't have any baby oil or you can't get any, cooking on things like sunflower oil will work just as well. You can see a little bit better with the baby oil. You'll also need some cups or glasses. Now, I'm going to use some of these clear bottles. A cup will be fine. The only thing that you need to make sure you can do is that your candy cane can hook onto the side of the glass or the bottle like that. And you'll need 3 of those. That's all you're going to need for the first 2 experiments. So we are going to get started. I'm just making sure I've got everything I have. Now, what you also don't have at home, or you might not have at home, is you might not have safety glasses. I am going to wear safety glasses because I believe that you should always really wear safety glasses when you're trying to do science, even if you're using household ingredients like these. If you have any, please wear them. If you don't, just make sure that you're doing everything not close to your face and nothing ever goes anywhere near our mouths, even though we're using tasty things like candy canes. When we're doing our science, it should never go anywhere near our mouths. So the first candy cane experiment is called disappearing candy canes. Now that doesn't mean eating them really, really quickly. We're going to use a little bit of science to try and make some of the candy cane disappear. So the first thing we need to do a little bit of prep work. Now before I start that, I'm going to put on my safety glasses. Now I know a lot of you might be thinking, why do you need to wear safety glasses when you're using things like water, baby oil or vinegar? Now vinegar is used all the time, but it's a type of acid. It's a type of acid called ethanoic acid or acetic acid. Now acid, if we get acid in our fingers, it can hurt our fingers. If it gets in a cut, it can sting a little bit, so it could also hurt our eyes. So that's why I'm going to wear goggles to try and keep the acid from definitely not going in my eyes. But again, if you don't have these, just be super, super careful and definitely get a grown-up to help you. So the first thing I've done is I've got my little bottles of water. And this one just has water, just tap water, room temperature tap water, up to quite close to the top. So what I'm going to do is I'm going to put the same amount of baby oil and vinegar into these different ones. So I'm just going to get the baby oil. This takes quite a while, so I'm going to give it a good squeeze, like getting it all out. So it's about the same amount in. Now when you're squeezing the baby oil, hopefully you'll notice that it seems a little bit thicker than the water. This is called viscosity. So it's more viscous. It's a thicker liquid than the water. So it all goes in. Then bubbles will settle. So I've got my bottle of baby oil. I've got my bottle of water. Now remember, baby oil, you can use the vegetable oil or sunflower oil or cooking oil instead. I'm just going to put that there. Try and be tidy. Next thing we're going to use is our vinegar. Now remember, you can use malt vinegar instead of this one, but it does work better with white vinegar. So again, I'm just going to give it a good squeeze. I've put the neck of the bottle in the other bottle, so it's going to keep my eyes nice and safe because it's going to it would be harder for it to splash into my eyes, because remember, this is vinegar. So I'm going to give it a big squeeze. It's an acid. Now when you pour it out, you may also notice that this one seems a lot more like water. It's a lot more thinner than the oil. So I'm just going to give it a nice squeeze. Taking longer than I thought there, sorry. So I'm going to give it a nice squeeze. Hopefully we can all be doing this together, but don't worry if you can't. This is just our prep work. So again, we're going to give it a nice squeeze, so it's quite close to the top. As close to the top as possible, this one really. So I'm going to give it a nice, nearly there. Last squeeze, last final one, and we are there. So we let it stop, the bubbles go up, and then we turn it out. So we've now got a bottle of baby oil, a bottle of water, and a bottle of vinegar. Now hopefully you'll kind of notice that they all look very, very similar. And this is another reason why I always think we should wear goggles. It's hard to tell without the smell which one's actually the vinegar. So whenever you're using chemicals, even if it looks like water, like these all do, we should always wear our goggles because it might not be water like the vinegar. Now, that's almost it for the prep work. The only other thing you need to do is you need to get your candy canes. Now, most candy canes will come with a kind of a plastic cover on it. We need to take that plastic cover off, otherwise this definitely won't work. And to do this experiment, all we need to do is we're going to hook the candy canes on the side of the bottle. So this long bit here, this goes into the bottle. So I'm going to get my oil, I'm going to get this candy cane, I'm going to put it in there. And you see how this bit's now in the oil and this bit's hooked on the top. We're going to do exactly the same with the water. Hook it on. Excellent. And one more time, I'm going to use the vinegar. Make it on, turn it around, hook it in. So can we all see? We now have the candy canes are now sitting in all of the liquids. Now this experiment to finish does take quite a long time, but hopefully what you'll start to see is you will start to see some changes happening really, really quickly. If you look at the oil, you won't really see much happening. Not much happening at all. However, if you look at the one in the water, hopefully you'll start to see it whole. You'll start to get these trails, these white, really faint white trails going through the water. And then with the vinegar as well, you'll also see that you'll start to get some of these trails coming through the water as well. And what that is, that's the sugar dissolving in the water. So the sugar, the water is at a very low concentration, and this candy cane, you might not be surprised to hear, is full of sugar. So what's happening, the sugar's moving from the strong concentration of sugar into the low concentration. Now, what you'll also hopefully notice is, if you keep on watching this super, super carefully, that, let's look these up, you'll start to just see that the colour of the water will change a little bit, and the vinegar will as well, and it'll change a little bit. And what will happen is, the colour won't change all the way through the water, it'll just start changing from the bottom. Now these two are just happening now, so you can start to see that the sugar is sinking to the bottom. That's a good one to show. The sugar is sinking and staying at the bottom, and that's because of this thing called density. So density kind of means how heavy something is. So the sugar, when the sugar moves into the water or the vinegar, it becomes a sugar solution, and the sugar solution is heavier than the water. So it sinks to the bottom because it's more dense than the water. Now, for this experiment to finish, it's actually going to take about another 30 minutes. So what I'm going to do is I'm going to have my nice cup of hot chocolate, and I'm going to wait 30 minutes, and then I'm going to come back, and hopefully you'll see something that definitely looks a little bit different compared to what it does now. So it's been 30 minutes, and I've finished my hot chocolate, and I might have burnt my tongue a little bit, but now hopefully you can see stuff has changed. So they don't look the same. These bottles here don't look the same as what they did 30 minutes ago. One of them might. So this one looks like nothing's happened. This is the baby oil one. But these two have definitely changed. The water and the vinegar have definitely changed. Now hopefully the first thing you can see is that they've changed colour. Now if I lift them up and bring them to you, you can see that they've turned a pink colour. I'm going to use this one, but you can see that just talking before about density, this pip here is water, so there's not much sugar in it, and all the liquid with the sugar from the candy cane in it is now turned pink, so it's white and red make pink. So it's a sugar solution and it's more dense than the water. So it's still stay there unless I give it a shake and then it would all mix together. That's because of this thing called density. But just while I'm holding there, you may have seen something else that's happened. So with the water, it gets a bit sticky this time. With the water and the vinegar, what should have happened is you should have seen that what's happened, they've disappeared. The bottom of the candy cane has disappeared. And that's because of what happened when it was in the liquid. The sugar has all dissolved, the water has broke down the sugar and it's dissolved, and the candy cane is basically 100% sugar. So it has disappeared because what's happened is it hasn't just disappeared completely, it's actually moved into the water. So they are very sticky, so we're left with two sugar solutions. So it's disappeared, but in a good way. Now this is really important. So this one hasn't really changed at all. And that's because the oil has stopped it from breaking down. So that's how lots of food are kept in oil to keep it nice and fresh. And that's what's happened with this one as well. The candy cane is being kept fresh by the oil. So the oil stopped other things getting to it. So it's kept it almost in perfect condition. I wouldn't eat that one because it has got baby oil on it. The water one is edible, but I wouldn't eat the vinegar one either. But that's a really nice experiment to just kind of show you how you can do different things with candy canes. You don't have to eat them all. The grown-ups might like me saying that. But it's a nice little thing at just showing a little bit of science. But what I'm going to do is we're going to use some of the science for the kind of big science favourite at the end. So that was our disappearing candy canes. It does get a little bit sticky, that one, so please be careful. But the next experiment we're going to do is we're going to do another experiment with candy canes and try to get them to move around a little bit. Now this experiment is our dancing candy cane experiment. Now unfortunately we can't get the full candy canes to dance. It would be impressive if we could, but unfortunately I can't. So what we need to do is we need to break our candy canes up into lots of tiny pieces. Now to do that, get a grown-up helper, put them into a plastic bag or a food bag or just somewhere where the stuff's not going to kind of spray anywhere. And you can use things like a rolling pin, or if you've got a grown-up you could use a hammer. I used one of these, which is kind of a meat tenderizer. So what I do is I put some candy canes in a bag and I give it a real good bash, just like that. Now, what will happen is it will break up into some little bits like this. It'll break into some big bits. Now, these big bits, they won't work either. So what I did was I just smashed it even more, and we got until we had lots and lots of tiny little pieces. Now, these tiny little pieces will work a lot better because what we're going to do is we're going to use science to make these kind of tiny pieces of candy cane come alive and start dancing around in some liquid. We're going to use a little chemical reaction. Now, for the chemical reaction, we are going to use some water. So all I did was, I've just got, again, this can be done in a cup or a glass or a plastic cup. Again, I'm using this bottle just so you can see better at home. I've just filled it about half full of water. That's the first thing we need to do. The second thing we need to do is we're going to put some vinegar into it as well. Now remember, vinegar is an acid, so I'm going to put my goggles on. I'm going to open the vinegar. I'm going to put the vinegar in, and I'm going to just give the vinegar a nice squeeze again. So now what we've got here is, I'm just squirting some vinegar into the water, so the vinegar isn't going to be as strong. So the concentration isn't going to be as strong because there's water in there as well. So it's just about half-y-half. So 1 part vinegar to 1 part water. I'm going to put my lid on. So this is the prep work done. Now, remember when we did the first experiment and I talked to things about density, and when the sugar went into the water, the sugar solution sank to the bottom because the sugar solution was more dense than the water. Well, that same thing goes for the candy cane. So I broke that candy cane around into lots and lots of tiny pieces. So when I drop this candy cane into the water and vinegar, it's more dense as well, so it will sink to the bottom. So what this experiment does is it gets the candy canes to sit on the bottom, but then it gets it to start to kind of moving about. It'll start to jiggle around on the bottom a bit. And what hopefully you'll see is some candy cane will even start to kind of rise up and float, so it becomes less dense. But to do that, we have to do a little bit of science. And that's where the baking powder or bicarbonate of soda comes in. Both them work for this. So what I'm going to do is carefully, I'm going to put about half a teaspoon of baking powder into the vinegar. Now remember I said the vinegar was an acid. So it's a type of chemical called an acid. baking powder is actually a type of chemical called an alkali, so they're kind of the opposites in chemical. However, when an acid and an alkali react, they make this thing called carbon dioxide. That's what makes this messy. Because when I put this baking powder into this acid, it reacts, makes carbon dioxide, which is in lots and lots of tiny bubbles, and it will rise and it will come over the top. It will happen either if you do in a cup. That's what the plate's for. Now, you don't have to do this quickly, but what you can do, pick this up, just drop it in, you'll see it will fizz and it will rise over the top. Hopefully don't do too much so it stays on the plate. But what you want to happen is you want all of these bubbles to just go away a little bit, just so you can start to see the liquid again. So it'll be a little bit less liquid. It's going to be hard to move around, but you can see it's full of tiny, tiny, tiny little bubbles. All them bubbles are carbon dioxide. So what we're going to do now is we're going to get some of our candy cane and we're going to throw it in. And hopefully what you'll see, they'll all start floating to the bottom because they're more dense. But then what will happen is, every now and again, you'll just start to see that you see the little red ones, they start to jiggle around on the bottom and then they start to rise up. They rise up at the top and then when they get to the top, they sit at the top and then they walk and then they fall back down. Hopefully you can see this at home. When you always look nice and carefully, you'll see that they'll rise up perfectly. You've got loads of little ones coming here. So what happens here, because the candy canes, they're full of sugar, so remember, they're more dense, so they fall to the bottom of the water. But then the carbon dioxide, because the candy canes have got quite a rough surface, the carbon dioxide bubbles attach themselves to the candy cane. So that means the candy cane becomes less dense, so that their volume becomes less. So because what happens is, it'll start to float up to the top, there you go, and it starts, when it gets to the top, the carbon dioxide bubble that's kind of sitting at, like a kind of rubber ring, if you go swimming, when you put your rubber rings on, it makes you float. The candy cane, so the carbon dioxide bubbles kind of become a rubber ring for the candy canes. It floats to the top, but when it gets to the top of the water, like, is the one going there? It'll go like top of the water, that one there, it pops. So it pops the rubber ring, it pops the carbon dioxide bubble, and then because it pops the bubble, the candy cane, remember, it's just all sugar, so it gets more dense, so it sinks. And this will happen over and over again. The last of our big science Christmas experiments is one of my favourites. It is making lava lamps. But we're going to make some big science lava lamps. I'm going to show you two different ways, both with a kind of Christmas twist. So the first thing you're going to need is you're going to need something to turn into your lava lamps. I like to use just empty plastic bottles. I've got these small ones here. You can use old water bottles or anything like that. If you don't have any plastic bottles, a glass or a plastic cup will work just as well. You just need to be able to see through, so a nice clear bottle. I just like using bottles because they can be kept for quite a long time. You also need some water and some food colouring, and you need some sort of oil. So I've got the baby oil of our first experiment, and I've also got just some sunflower oil. Any cooking oil works for this. Olive oil works, sunflower, vegetable, any sort of cooking oil works just fine. Then we need one more thing. We need something to make things fizz, something to start turning our water into lava, making it come alive. So you can use effervescent tablets. So I've got some of these. Also, Alka-Seltzer to work really, really well. Now, if you ever use any of these, you really do need a grown-up. So this is definitely for a grown-up helper only. So the first thing I'm going to do is I'm going to pour some water into the bottles. It doesn't need to be much. Just about that much in the bottom works just perfect. So there we go. I'm going to leave that one there. So just see, I've got some water in the bottom. Now I'm going to put some food colouring in. So as it's Christmas, I thought we'll have one red. Give it a little swirl. And one green. Give that one, try to tidy. Give that one a little swirl as well. So I've got a nice red, a nice green, nice Christmassy colours, matches my candy cane. Now, that's water. As you can see, the water's fell at the bottom, so the water is more dense than the air, because there's air in there as well. It's not empty, it's full of air, and then that's water underneath it. So I'm going to start adding the oil. Now, first I'm going to go for the baby oil. So it just looks like water, but I'm going to pour it in. leaving a gap at the top of about 1 inch, and you can just see that the oil has just sat on top of the water. Now remember, that's because of this thing called density. So what that shows is that the water is more dense, it's heavier than the oil, so it sinks to the bottom. Now, I've got my, need to knock that over, sunflower oil. I'm going to just do the same. I'm going to pour it in with the red, and till about 1 inch from the top. That'll move around, and see again that the water is sank to the bottom. I've got a little bit of plastic in there as well. The water has sank to the bottom of the sunflower oil, which again shows that the water is more dense than the sunflower oil. So you can see they both look pretty similar, but here we've got a nice clear with green, and this is a nice kind of golden yellow colour with the red underneath. Now, that's our lava lamps kind of ready to go. However, they look good now, but we want to make this lava, the water, come alive. And what we do is we use these tablets. Now remember, these tablets are for grown-ups, so these tablets have kind of some chemicals inside. One of these chemicals in the Alka-Seltzer tablets is a medicine for grown-ups. That's why you should never ever touch these without a grown-up helper. Because I have a type of medicine called aspirin, which is for grown-ups. But they also have two other things. They have something called citric acid, which is an acid, and they have something called sodium hydrogen carbonate, which is baking powder. It's an alkali. So they have chemicals in these. I'm just going to put one there. Now these tablets here, these vitamin C tablets, these have vitamin C in, might not be surprised, but they also have two other things in them. One of them is called citric acid, and the other one is called sodium hydrogen carbonate. So some of the chemicals are the same. That's why it works very well for this experiment. Now, those chemicals, in the last experiment, when we had the vinegar, the acid, and we put a spoonful of the baking powder in, it fizzed straight away. So them two chemicals reacted with each other. Now, if you look at these two tablets, nothing's really happening. And that's because in these tablets, there's no water. They're really, really dry. So the chemicals are nice and dry. So what we would say as a scientist, because these chemicals are dry in these tablets, they are not reacting with each other. They're just being a little bit boring. They're not having fun, and they're not reacting. But to get these chemicals to react, we need to get them wet. So what's going to happen is when I drop these tablets into these bottles, it will go through the oil. Now remember, when I tried to make the candy cane react in the oil, it didn't react in the oil. It was just half an hour later, it was just looked like nothing had happened to it. So these won't react in the oil, but they'll sink through, and when they hit the water, like the candy cane, they'll start to react. So the water will make the acid and the alkali mix together, which will make carbon dioxide. Now, carbon dioxide is a gas. So carbon dioxide, like with the candy cane, it will attach itself. So the carbon dioxide will be in the water. So the water will no longer be just water. It will be water and carbon dioxide. So it will become less dense than the oil. And remember, less dense things float. So the water will come alive because it won't be heavy anymore. It'll be lighter than the oil. So it will float to the top. And then when the water with the carbon dioxide get to the top, the carbon dioxide will hit the air. All the little carbon dioxide will pop. So all the carbon dioxide will stay on top. And then the water will have no carbon dioxide in. So it will get heavier again and it will sink. Fingers crossed. So here we go. So we get them. We put them in. And then, I'm going to hold it by the bottom, you can see that all the bubbles start. The green started straight away, and then all the little green bubbles that are going up are full of carbon dioxide. That one's going super, super fast. Now you will see that the green ones are going much, much faster than the red ones, and that's because of the different types of tablets. The Alka-Seltzer tablets work very, very quickly, and that's why you're getting all these super, super, super fast little green bubbles that are moving all over and coming back down. And you can see the carbon dioxide at the top. Now the vitamin C tablets, they take a little bit longer to get going. So what happens is you'll see that the bubbles happen much, much slower, but they will last much, much longer because all of it will still be there when this is all gone. So that one's almost stopped straight away, and you can see now very few bubbles are going up. They're all going down. They're all falling back into the water, while the red one is still going nice. Now to make these even more crispy, that's going lovely, that one. To make these even more crispy, you can add things like glitter in as well. The glitter will kind of stay in both. But that's a lovely, lovely little experiment. Now, if you do them in water, in bottles, the oil keeps the water fresh for quite a long time. So you can put the lid back on, but never put the lid back on while the bubbles are going nice and fast, because the carbon dioxide that's left at the top needs somewhere to go. And if you put the lid back on, it hasn't got anywhere to go, so the bottle can split. But when it slows down like this, then you can put the lid back on, and then it's ready to keep. Now I'm just going to put that one there because this one's still going nice and fast. You can see the vitamin C tablets, there's still lots of bubbles, so I wouldn't put the bottle top back on this. But it's a nice Christmassy one, nice little Christmas decorations that you can make at home using a little bit of science. So that was our 3 big science Christmas experiments. I would like to say thank you so much to the Christmas in Sundeland programme for asking us to come along to do these experiments. Hopefully you've all had as much fun as I have. Now, what I would like to say is, when you do science, always remember to wear your goggles, always have fun and do it safely. Hopefully the grown-ups are a little bit on my side. That just goes to show that even all the sugar you do get at Christmas, you don't have to eat it. Sometimes you can have fun doing science as well. Now, I did think Santa was going to show up today. He hasn't, but he must be really, really busy. But from me and everyone here at Big Science, I would like to say Happy Christmas to everyone and hope you have an amazing New Year. So thank you so much and see you soon. Bye.